All right, welcome back. This is the last video for section 5, which is covering mole conversions. And if you're just joining us in this video, just FYI, we already did number 4 in the last video. So if you wanted to see how that one's done, check that one out. So we're going to pick up with number 5. Number 5 is asking us how many ions are there in 2.50 grams of calcium bromide. Now this is a new one. You've never heard of ions before in terms of a mole conversion. But just think of ions as the same thing as atoms. Why do they say ions instead of atoms? Well, because calcium bromide is technically an ionic compound, so it's composed of not atoms, but ions. You'll learn more of that specifically in topic 5. So for right now, it's just a technical thing. So we're going to solve it very similar to how we've done before. So we're going to start with the 2.50 grams of calcium bromide. Okay, and the first thing I need to do, and hopefully we're getting pretty good at this, is convert from grams to moles using our molar mass. So grams of calcium bromide to moles of calcium bromide. And 1 mole of calcium bromide, let's figure out what that's going to be. Calcium is 40.08. Bromine, 1 bromine is 79.9, but we have 2 of them. So the molar mass is roughly 199.88. All right, that's going to help our grams to cancel. And now we're in moles. And so once you're in moles, now we can get to particles. So 1 mole of anything, in this case we're in calcium bromide, is going to be 6.022 times 10 to the 23rd of that thing. Well, what is that thing? Calcium bromide, that's a molecule. So it's 6.022 times 10 to the 23rd molecules of CaBr2. So moles of calcium bromide cancel, and now I'm in molecules of calcium bromide. But that's not where we stop. We don't want to know how many molecules. We want to know specifically how many ions or how many atoms. You can think of it that way. Okay, so that's the last step. We want to say, okay, if we had just 1 molecule of calcium bromide, how many ions or how many atoms would it have? Now notice it's not saying how many calcium ions, how many bromine ions, it's just saying how many ions. Well, taking a look at the formula, CaBr2, 3. 1 calcium and 2 bromines. So it would contain 3 ions. So it's not being specific in this one, it's just saying ions in general. So molecules would cancel, and now I'd be left in just the number of ions that are there. So we're going to take 2.50 times 6.022, E23, times 3 ions, and then divide that by our molar mass of 199.88. Significant figures, we're going to have 3 sig figs in this problem. So my answer is 2.26 times 10 to the 22nd ions. And we don't have to say ion because it's both of calcium and bromine, so we can just say ions. All right, let's take a look at this one. What is the mass of nitrogen dioxide, or NO2, that contains 3.56 times 10 to the 24th oxygen atoms? So this one is basically like number 5, but we're going opposite. We're going in the reverse. We already know that there are this many oxygen atoms, just like we know that there are this many ions. We need to work backwards and say, okay, first of all, let's get from oxygen atoms to the actual compound that we're talking about. Then we can convert to moles, and then we convert finally to mass. So let me show you how that's done. So we're going to have 3.56 times 10 to the 24th oxygen atoms. That's what we're starting out with. All right. Well, I want to get out of oxygen atoms because that's not what my problem's asking about. I want to get into nitrogen dioxide molecules. And I know for every 1 molecule, there's going to be 2 oxygen atoms. So you see how I got from oxygen atoms specifically into the whole molecule that the question's asking about. It's asking to ultimately solve for nitrogen dioxide. So I've made that switch. So now I'm in molecules of nitrogen dioxide. And so now what I can do is I can say, all right, if I have 6.022 times 10 to the 23rd nitrogen dioxide molecules, that's the same thing as saying I have 1 mole of nitrogen dioxide, right? And so nitrogen dioxide molecules cancel, and now I'm in moles of nitrogen dioxide. And so then the final step is 1 mole of nitrogen dioxide. Whoop, forgot the O. Nitrogen dioxide, there we go. We'll have a mass of, and that's what we need to figure out. So let's see what it would be. Nitrogen is 14.01, oxygen is 16, but there are 2 of them. So our molar mass of NO2 is 46.01. So my moles will cancel, and now I'm in grams. And so now, let's do our math. 3.56 times 10 to the 24th times 46.01 divided by 2, and then divided by, again, 6.022 E23. And so with 3 sig figs, it looks like my mass is going to be 136 grams of NO2. All right, let's take a look at more practice. Lots of practice for mole conversions, because that's how important it is. These ones are asking it a little bit differently. If 6.022 times 10 to the 23rd atoms of element X had a mass of 83.80 grams, what is the identity of element X? Remember how I said before when we were talking about molar mass, that molar mass could be helpful in helping us figure out what element we're looking at. So in order to identify what element X is, I have to figure out its molar mass. Well, how do you figure out molar mass? Well, what is molar mass? It's grams per mole, right? Well, I know how many grams I have. It tells me that I have 83.80 grams of element X. What quantity of element X does that equal? 6.022 times 10 to the 23rd atoms. Isn't that the same thing as saying 1 mole of element X, right? Because that's what 1 mole equals. So basically when it says if 6.022 times 10 to the 23rd atoms of element X, let's just rephrase that and say if 1 mole of element X has a mass of 83.80 grams. So what I just said is, okay, 1 mole of element X has a mass of 83.80 grams. That's the definition of molar mass, right? I just essentially figured out element X has a molar mass of 83.80 grams per mole. So the question is, all right, so there really wasn't a lot of math. There was no math, actually. It just was understanding concepts, right? So I just have to look at the periodic table and say, well, okay, what element has a mass of 83.80? And it looks like krypton, element krypton, Kr. That is the identity of element X. And I want to point out something here too. Notice the question. It said, what is the identity of X? A lot of times students, they just do this. They figure out the molar mass and they're like, great, I did the problem. No, you didn't. You didn't answer the question. The question was saying, what is element X? So make sure not only do we, solve for the molar mass, but we need to answer the question. We need to actually identify the element. Let's look at letter 8. Number 8. Whew, it's getting late. Very similar, but we're going to have to do a little bit more in this problem. So it says if 8.660 times 10 to the 20th atoms of element Z has a mass of 0.1530 grams, what is the identity? So very similar, right? We need to figure out what is the molar mass, grams per mole, because then once we know that, we can solve the problem. Well, I know what the mass is, 0.1530. I need to know how many particles does that equal? How many moles, what quantity is that equal to? Well, this time it gives me the particles, but it doesn't give me the particles in a nice number like it did before. Before, it gave me basically the definition of 1 mole, but I don't know how many moles this is. I don't know. It's something less than 1 mole, I know that, but I don't know what it is. So off to the side, what I'm going to do is I'm going to say, okay, 8.660 times 10 to the 20th atoms. I'd like to figure out how many moles is that. So I know that 6.022 times 10 to the 23rd atoms would be 1 mole. So let's divide that. So 8.660 times 10 to the 20th, divided by Avogadro's number, I would end up figuring out that 8.660 times 10 to the 20th atoms of element Z is the exact same thing as saying 0.00143806. I kind of go out a little bit. Moles, right? I converted. I said this is the same. This number of atoms of element Z is the exact same thing as saying this many moles of element Z. They're the same thing. It's just a different unit. So now I have a mass that I know is equal to an amount of moles. But that's kind of gross, right? It looks a little messy. So if I divide these two, I'll end up getting a grams per mole. That's a lot cleaner. So let's take the mass that we know is 0.1530 divided by the number of moles we know it's equal to, 0.00143806. I end up getting that the molar mass is 106.4 grams per mole. Essentially, remember, this right here is the exact same thing as this. It's the same thing mathematically. It's saying, okay, if this is true, then 1 mole of it should weigh this much. But here's what we need to do. We need to figure out what is element Z. So what element is close to that? Let's see, 106. Looks like PD. PD, that's going to be our element. That is element Z. All right, these last two questions here are going to look at molarity and molar volume. So how many grams, okay, that's the mass. How many grams of sodium hydroxide, NaOH, would be in 50 milliliters of a solution of sodium hydroxide that has a molarity of 1.50 molar? Okay, so I'm going to need to help you out a little bit on this one. So 1.50 molar, that's the same thing as saying there are 1.50 moles for every 1 liter, right? Because we talked about earlier, that's what molarity is. Molarity is telling us moles over liters. So this could be rewritten as 1.50 moles over 1 liter. That's going to help us do some converting. So ultimately, I need to take my 50.00 milliliters and I need to convert that into grams. Well, the first thing I have to do is find a way to convert that to moles. Be careful. A lot of times students see milliliters and they think, oh, I'm going to use that 22.41 number. That only works for gases. This is not a gas. This is a solution. So what I'm going to do is I'm going to first convert milliliters to liters. And I know 1 liter contains 1,000 milliliters. Why do I do that? Why do I need to get it into liters? Because now that I'm in liters, I can use the molarity and say, okay, 1 liter contains 1.50 moles. You see how I did that? So I was able to use some mole conversions to convert milliliters to liters to ultimately use my molarity to convert to moles. And now that I'm converted to moles, this next step should hopefully look familiar to you. 1 mole of the sodium hydroxide weighs, and the molar mass of sodium hydroxide is it's pretty much 40.00 grams. Let me erase this so I can have some space to write my answer. All right, moles will cancel. So I will be in grams as my answer. And when I calculate this, I actually get exactly 3, but I need to keep significant figures. We have 4 significant figures here, but 3 significant figures there. And so between these two, 3 is the lowest. So I'm going to make it 3.00 because it needs to have 3 sig figs, grams of sodium hydroxide. And then let's take a look at this last one. This last one's going to be very quick. How many hydrogen molecules would there be in a volume of 25.4 milliliters at STP? Couple things to note. Hydrogen molecules, that's a gas. Remember, hydrogen is a gas. And STP means I can use 1 mole of any gas equals 22.41 liters. I can use that conversion. So this is how we're going to set it up. So here's our setup. First thing I need to do is convert 25.4 milliliters to liters. Once I'm in liters, I'm able to use my conversion factor of 22.41 liters is equal to 1 mole. And then finally, I use the molar mass of hydrogen. Hydrogen is a diatomic. It's H2. So make sure when you do the molar mass for hydrogen, it's H2, which means 2.02. And when I calculate all of that, I end up getting 0.00, and I need to have 3 sig figs, so 229 gram.